But dear students, it is L4, lesson 4. Okay. So we have studied convergent sequences. You should be knowing not only convergent but also non-convergent sequence. You need to study non-convergent sequences today. A sequence which is not convergent is called divergent. So convergence or divergence. Convergence means moving towards a point. Divergent ಅಂದ್ರೆ moving away. You have studied in physics convergent rays, divergent rays. Divergence means moving away. Okay. So today we discuss non-convergent sequences. A sequence which is not convergent is called divergent. Of which we make two categories: bounded sequence and unbounded sequence. A bounded sequence which does not converge and has at least two limit points is said to be oscillating finitely. Okay, oscillating finitely ಅಂದರೆ ಹೇಗೆ ಬರುತ್ತೆ ಅಂದರೆ, you look at your sequence minus 1 to the power n. What are the members? Minus 1 plus 1, minus 1 plus 1, minus 1 plus 1, etc. Here the values are oscillating between minus 1 and plus 1. There is no unique limit here. Unique limit illa. Okay, we have two limit points. On the minus 1, another one is 1. And it is bounded because every term of the sequence is in between minus 1 and 1. It's a bounded sequence. It has got two limit point, right? So it does not have a unique limit value. So what you can say, it is oscillating finitely. Whenever sequence is bounded and has at least two limit point, then it is said to be oscillating finitely. Okay, fine. Unbounded sequence ನೋಡಿ. If a sequence Sn is unbounded on the leftally unbounded, you take sequence of natural numbers, right? Minus n ತಗೊಳ್ಳಿ, minus n. Okay, if you take the sequence minus n, okay, what is the first value? Minus 1, and then minus 2, minus 3, minus 4, right? Etc. etc. So every term of the sequence is less than or equal to minus 1. It is not bounded below. It is not bounded below. If a sequence is unbounded on the left, not bounded below, then minus infinity is the limit point of the sequence. Minus infinity is the limit point of this sequence, right? And also minus infinity is the least limit point, so that limit infimum Sn is minus infinity. Leftally bound ಆಗದಿದ್ದರೆ minus infinity is the limit point and it is the least limit point, and therefore limit infimum of the sequence is minus infinity. Parallel to this, we make a statement. If a sequence Sn is unbounded on the right, sequence Sn is unbounded on the right, then not bounded above. You think of a sequence of natural numbers 1, 2, 3, 4, etc. It is not bounded above. Right? What do you say now? Plus infinity is a limit point of the sequence, and it is the greatest limit point also. If you think of this natural number set, plus infinity is said to be the limit point, and it is also the greatest limit point. Therefore, limit superior Sn is plus infinity. Okay? If a sequence is not bounded below, limit inferior is minus infinity. If a sequence is not bounded above, limit superior is plus infinity. So, okay, fine. Coming to third case, if a sequence Sn is bounded above but not below, bounded above but not below, fine. If it is not bounded below, it is like this now, not bounded below. What is the limit point? Minus infinity. Besides minus infinity, suppose it has no other limit point. ಬೇರೆ ಯಾವುದೇ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಇಲ್ಲ, ಓನ್ಲಿ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ಇಸ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಅಂತ ಇದ್ದರೆ, then it is also the greatest limit point. Fine. So in this case, limit inferior equal to limit superior, both equal to minus infinity, ಯಾಕಂದರೆ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ಇಸ್ ಓನ್ಲಿ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್, ದೆರ್ ಈಸ್ ನೋ ಅದರ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್. ಇನ್ ಸಚ್ ಕೇಸ್ limit inferior, limit superior, that is the upper limit, lower limit, both are equal to minus infinity. That is also equal to limit of the sequence. Fine. Inferior Sn. So in this case we say that sequence Sn is diverging to minus infinity. ಯಾವಾಗ sequence minus infinity ಗೆ diverge ಆಗುತ್ತೆ? If it is bounded above but not bounded below, and minus infinity is the only limit point. Other than minus infinity there is no other limit point. ಆವಾಗ ಏನಾಯಿತು, ಲಿಮಿಟ್ ಸುಪೀರಿಯರ್ ಮತ್ತು ಲಿಮಿಟ್ ಇನ್ಫೀರಿಯರ್ ಕೋಯಿನ್ಸೈಡ್ ಆಗುತ್ತೆ. ಲಿಮಿಟ್ ಇನ್ಫೀರಿಯರ್ ಈಕ್ವಲ್ ಟು ಲಿಮಿಟ್ ಸುಪೀರಿಯರ್, ದಟ್ಸ್ ಈಕ್ವಲ್ ಟು ಲಿಮಿಟ್ ಆಫ್ ದ ಸೀಕ್ವೆನ್ಸ್, ಆ್ಯಂಡ್ ದ್ಯಾಟ್ಸ್ ಈಕ್ವಲ್ ಟು ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ. ಹೀಗಿದ್ರೆ ವಿ ಸೇ ದ್ಯಾಟ್ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಡೈವರ್ಜೆಂಟ್ ಟು ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ. Sequence is divergent to minus infinity under this case. Similarly, if the sequence is bounded below ಆಗಿದೆ but not bounded above, and besides plus infinity there is no other limit point. Bounded below but not bounded above, 1 2 3 etc. ಇರೋ ಹಾಗೆ. ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ಬಿಟ್ಟು ಬೇರೆ ಯಾವುದೇ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಇಲ್ಲ ಅದಕ್ಕೆ. ಆಗ ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ಇಸ್ ಓನ್ಲಿ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಯುವರ್ ಹ್ಯಾವಿಂಗ್ ಆದರೆ, ಆಗ ಲಿಮಿಟ್ ಸುಪೀರಿಯರ್ ಇಸ್ ಆಲ್ಸೋ ಈಕ್ವಲ್ ಟು ಲಿಮಿಟ್ ಇನ್ಫೀರಿಯರ್, ದಟ್ಸ್ ಈಕ್ವಲ್ ಟು ಲಿಮಿಟ್ ಆಫ್ ದ ಸೀಕ್ವೆನ್ಸ್, ದಟ್ಸ್ ಈಕ್ವಲ್ ಟು ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ. In this case we say that sequence is divergent to plus infinity. Okay, ಸೊ 4 ಕೇಸಿಗೆ ನಾವು ಪ್ಲೇಸ್ ಮಾಡಿದ್ವಲ್ಲ, ಯಾವುದೆಲ್ಲ ಹೇಳಿ. ಒಂದು ಲಿಮಿಟ್ ಇನ್ಫೀರಿಯರ್ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ಯಾವಾಗಂದರೆ ಇಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಅನ್ಬೌಂಡೆಡ್ ಆನ್ ದ ಲೆಫ್ಟಲ್ಲಿ ಬೌಂಡ್ ಆಗಿಲ್ಲ, ರೈಟಲ್ಲಿ ಮಾತ್ರ ಬೌಂಡ್ ಆಗಿದೆ. ಆಗ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ಈಸ್ ಅ ಲೀಸ್ಟ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಆ್ಯಂಡ್ ಲಿಮಿಟ್ ಇನ್ಫೀರಿಯರ್ ಇಸ್ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ. ಇಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಅನ್ಬೌಂಡೆಡ್ ಆನ್ ದ ರೈಟಲ್ಲಿ ಬೌಂಡ್ ಆಗಿಲ್ಲ, ಅನ್ಬೌಂಡೆಡ್ ಆನ್ ದ ರೈಟ್ 1 2 3 ಎಕ್ಸೆಟ್ರಾ ಇರುವಾಗ, ಆಗ ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ಇಸ್ ದ ಗ್ರೇಟೆಸ್ಟ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್. ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ಈಸ್ ಎ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಆ್ಯಂಡ್ ಇಟ್ ಈಸ್ ದ ಗ್ರೇಟೆಸ್ಟ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್. ಆಗ ಲಿಮಿಟ್ ಸುಪೀರಿಯರ್ Sn is plus infinity. Okay. Next question comes, when a sequence is divergent to minus infinity and when it is divergent to plus infinity. Divergent to minus infinity, divergent to plus infinity when ಅಂತ. If a sequence is bounded above but not below, ಬಿಲೋದಲ್ಲಿ ಬೌಂಡೆಡ್ ಆಗಿಲ್ಲ, ಲೆಫ್ಟಲ್ಲಿ ಬೌಂಡ್ ಆಗಿಲ್ಲ, ಆಗ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ಇಸ್ ಎ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್, ರೈಟ್? ಆ್ಯಂಡ್ ಬಿಸೈಡ್ಸ್ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ದೇರ್ ಇಸ್ ನೋ ಅದರ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್. ಆಗ ಲಿಮಿಟ್ ಸುಪೀರಿಯರ್ ಮತ್ತು ಲಿಮಿಟ್ ಇನ್ಫೀರಿಯರ್ ಎರಡು ಸೇಮ್, ಎರಡು ಕೂಡ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ಬರುತ್ತೆ. ಆ ಕೇಸಲ್ಲಿ ನಾವು ಏನು ಹೇಳ್ತೇವೆ ಅಂದರೆ ಸೀಕ್ವೆನ್ಸ್ Sn ಇಸ್ ಡೈವರ್ಜೆಂಟ್ ಟು ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ. ಅದೇ ರೀತಿ ಇಫ್ ಎ ಸೀಕ್ವೆನ್ಸ್ ಇಸ್ ಬೌಂಡೆಡ್ ಬಿಲೋ ಬಟ್ ನಾಟ್ ಅಬೌವ್, ರೈಟಲ್ಲಿ ಬೌಂಡ್ ಆಗಿಲ್ಲ, ಆಗ ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ಈಸ್ ಅ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್, ಲಿಮಿಟ್ ಸುಪೀರಿಯರ್ ಇಸ್ ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ. ಸೊ ಅದರ್ ದೆನ್ ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ, ಇಫ್ ದೆರ್ ಇಸ್ ನೋ ಅದರ್ ಲಿಮಿಟ್ ಪಾಯಿಂಟ್, then limit superior is also equal to limit inferior, both equal to limit of the sequence, that's equal to plus infinity. And in this case we say that the sequence is divergent to plus infinity. In this case we say that sequence is diverging to plus infinity. So okay, coming to the last case, an unbounded sequence, okay, is said to oscillate infinitely. Okay, unbounded sequence oscillating infinitely ಯಾವಾಗ ಅಂದರೆ it diverges either to plus infinity or to minus infinity. ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ವೇರಿ ಆಗುತ್ತಾ ಇದ್ದರೆ it is said to be oscillating infinitely. An unbounded sequence is said to oscillate infinitely if it is either divergent to plus infinity or minus infinity. So what is the conclusion? Thus a bounded sequence either converges or else it oscillates finitely, but an unbounded sequence either diverges to plus infinity or minus infinity, or it may oscillate infinitely. Is that right? Convergent case, oscillating finitely, it is possible under a bounded sequence. In an unbounded sequence, it is either divergent to plus infinity or minus infinity, or oscillating infinitely. Right? Okay. Study these definitions carefully. Then I will go for illustrations. you will get question like classify the following sequence as convergent, divergent and oscillating. ಇದು ಮೂರು ಕ್ಲಾಸಿಫಿಕೇಶನ್ ಕೇಳ್ತೇವೆ. ಈಗ ಫಸ್ಟ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, 1 + -1 to the power n. ಈ ಸೀಕ್ವೆನ್ಸ್ದು nth ಟರ್ಮ್ ಎನ್. ಎನ್ ಆಡ್ ಇದ್ದರೆ ಇದು 0 ಆಗುತ್ತೆ, ಈವನ್ ಇದ್ದರೆ ಇದು ಪ್ಲಸ್ ಆಯಿತು. ಈ -1 ಸ್ಕ್ವೇರ್ +1, 1 + 1 2. So one of the two values it will take, either 0 or 2. 0, 2, 0, 2, etc. These are the members of the sequence. Clearly every member lies between 0 and 2. 0 is a lower bound, 2 is an upper bound. So sequence is bounded. Moreover, already you have studied this. 0 and 2 are the two limit points of the sequence ಅಂತ ಕಲ್ತಿದ್ದೀರಾ. For this sequence, 0 and 2 are the limit point. Why they are the limit point? The neighborhood of 0 contains infinitely many terms of the sequence. Neighborhood of 2 contains infinitely many terms of the sequence. Fine? Since there are two limit points, limit point is not unique. Limit point is not unique, understand? Therefore, the sequence oscillates finitely. Why it is oscillating finitely? Because it is bounded and does not have unique limit point. Therefore, oscillating finitely. ಸೊ ನಿಮಗೆ ಅವರು ಹೇಳ್ತಾರೆ ಕ್ಲಾಸಿಫೈ ದ ಸೀಕ್ವೆನ್ಸ್ ಆಸ್ ಕನ್ವರ್ಜೆಂಟ್, ಡೈವರ್ಜೆಂಟ್ ಆರ್ ಆಸಿಲೇಟಿಂಗ್. ಸೊ ಯು ಹ್ಯಾವ್ ಟು ಸ್ಟಡಿ ದ ಕೇಸ್. ಅದು ಬೌಂಡೆಡಾ ಅನ್ಬೌಂಡೆಡಾ ಚೆಕ್ ಮಾಡಬೇಕು. ಲಿಮಿಟ್ ಪಾಯಿಂಟ್ ಒಂದೇ ಇದೆಯಾ, ಎರಡು ಇದೆಯಾ ಅಥವಾ ಇಲ್ವೇ ಇಲ್ವಾ ಅದು ನೋಡಬೇಕು. ಅದು ಎರಡನ್ನು ನೋಡಿಕೊಂಡು ನೀವು ಡಿಸೈಡ್ ಮಾಡಬೇಕು. ಹಿಯರ್ ಇಟ್ ಈಸ್ ಆಸಿಲೇಟಿಂಗ್ ಫೈನೈಟ್ಲಿ. ಓಕೆ, ಸೆಕೆಂಡ್ ಎಕ್ಸಾಂಪಲ್ ನೋಡಿ, -1 to the power n into 1 + 1/n. ದಿಸ್ ಆಸಿಲೇಟ್ಸ್ ಫೈನೈಟ್ಲಿ. ಯಾಕಂದರೆ ಅದು ಬೌಂಡೆಡ್ ಉಂಟದು. Every term of the sequence lies between -2 and 3/2. You have studied this example yesterday. So it is sequence is bounded. Okay. And sequence has two limit points, -1 and 1. Because infinitely many terms are around -1. Infinitely many terms of the sequence are around +1 as well. So two limit points are there. Limit point is not unique. Therefore, as it is bounded and does not have unique limit point, the sequence oscillates finitely. Conclusion, sequence oscillates finitely. Okay. Coming to third example. Look at the sequence. n into -1 power n. See, when n is odd, say n equal to 1 ಅಂತ ತಗೊಳ್ಳಿ. n equal to 1 ಆದರೆ ಇದು -1 ಆಯಿತು. n equal to 2 ತಗೊಂಡ್ರೆ +1 ಆಯಿತು. As n is tending to infinity, ಇದರ ಲಿಮಿಟ್ ತಗೊಂಡ್ರೆ ನೀವು -1 to the power n will give you a sign. -1 to the power n will give you a sign, either minus or plus. If n is odd, you will get minus sign. n even idre plus sign barutte. Next, as n is tending to infinity, this is tending to infinity. ಇದು ಮೈನಸ್ ಸೈನ್ ಇರುವಾಗ ಮೈನಸ್ ಇನ್ಫಿನಿಟಿ ಆಯಿತು, ಪ್ಲಸ್ ಸೈನ್ ಇರುವಾಗ ಪ್ಲಸ್ ಇನ್ಫಿನಿಟಿ ಆಯಿತು. ಸೊ ಲಿಮಿಟ್ ಆಫ್ ದ ಸೀಕ್ವೆನ್ಸ್ ಎಸ್ ಎನ್ is either minus infinity or plus infinity. Fine. ನೋಡಿ ಇದರ ಮೆಂಬರ್ಸ್ ನೋಡಿ ಇಲ್ಲಿ ಹೀಗೆ ಉಂಟು, 1, 2, -3, 4, -5 ಎಕ್ಸೆಟ್ರಾ. ಈ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ ಅಲ್ವಾ, ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂ ಡಿಕ್ರೀಸ್ ಆಗ್ತಾ ಹೋಗ್ತದೆ. -1, -3, -5 ಎಕ್ಸೆಟ್ರಾ. ಪಾಸಿಟಿವ್ ವ್ಯಾಲ್ಯೂ ನೋಡಿ 2, 4, 6 ಎಕ್ಸೆಟ್ರಾ ಬರುತ್ತೆ, ಅದು ಇನ್ಕ್ರೀಸ್ ಆಗ್ತಾನೆ ಹೋಗ್ತದೆ. ದೆರ್ ಈಸ್ ನೋ ಹಾಲ್ಟ್ ಫಾರ್ ಇಟ್. ದೆರ್ ಈಸ್ ನೋ ಬ್ಲಾಕ್ ಫ್ರಮ್ ದ ರೈಟ್, ನೋ ಬ್ಲಾಕ್ ಫ್ರಮ್ ದ ಲೆಫ್ಟ್. There is no right wall, no left wall, no upper bound, no lower bound. So sequence is unbounded. It's an unbounded sequence where the limit points either minus infinity or plus infinity baroga, a sequence diverges to minus infinity or plus infinity. Right? Hence, the given sequence oscillates infinitely. Oscillates infinite andre it may take value minus infinity or plus infinity, the limit, and it is unbounded, right? Unbounded and moving towards minus infinity or plus infinity, it oscillates infinitely. Okay. A fourth example nodi. This also you studied yesterday, -1 to the power n minus 1 by n factorial. There are members ಇಲ್ಲಿ ಉಂಟು, alternatively positive negative ಬರುತ್ತೆ. The minimum value -half, maximum value 1. All the terms are lying between -half and 1. So bounded below, bounded above. If a sequence is bounded below as well as bounded above, bounded below as well as bounded above, then it is a bounded sequence. Right? the limit of the sequence as n is tending to infinity is 1 by n factorial. As n is tending to infinity is going to be 0. So you have a limit, unique limit point. Sequence is bounded, having unique limit point 0. Therefore, unique limit value is 0. So your limit superior equal to limit inferior, that's equal to limit of the sequence, that is 0. Hence sequence is converging to the limit 0. Bounded sequence having unique limit point is converging to limit 0. Answer is convergent. What is the behavior of this sequence? It is a convergent sequence converging to 0. Okay, you take n square. The members are 1, 4, 9, 16, etc. This is clearly not bounded. This is not bounded above. So as n is increasing, values are increasing. You keep on increase n square is also increasing. It is not bounded above, it is bounded below. 1 is the lower bound. Fine. What is the limit of n square? As n is tending to infinity, n square is also tending to infinity, it is plus infinity. You are moving to the right, so plus infinity. Hence n square diverges to plus infinity. Either limit inferior and limit superior both are plus infinity. There is no other limit point. The limit point is infinity, plus infinity. Besides plus infinity, there is no other limit point. Therefore, limit inferior is equal to limit superior. That's equal to limit of the sequence, right? That is plus infinity. So, sequence is diverging to plus infinity. Okay, coming to sixth example, minus 2 power n. When n equal to 1, minus 2, the minus 4, minus 8, ಹಾಗೆ ಹೋಗುತ್ತೆ ಅಲ್ವಾ. ಸೊ ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಸಲ್ಲಿ ಮೂವ್ ಆಗುತ್ತೆ ನಾವು. ನೆಗೆಟಿವ್ ವ್ಯಾಲ್ಯೂಲಿ ಮೂವ್ ಆಗುತ್ತೇವೆ. Values are keep on decreasing, reducing. Okay. So ಇಲ್ಲಿ upper bound minus 2 ಸಿಗ್ತದೆ. Upper bound is minus 2. It is not bounded below. Right? What is limit 2 power n ಅಂತ? As n is tending to infinity, as n increases, 2 power n also increases. As n is increasing, 2 power n is increasing. As n is tending to infinity, 2 power n is also tending to infinity. But ಇಲ್ಲಿ minus sign ಇರುವಾಗ minus infinity ಬರುತ್ತೆ. So minus infinity is the only limit point you are having. So your limit superior as well as limit inferior is equal to minus infinity. Actually this is equal to limit of the sequence. It's equal to limit of the sequence. It's the limit of the sequence. Limit Sn is. Limit Sn minus infinity. That's also equal to limit inferior and limit superior. And also limit superior. So sequence is not bounded, right? And hence it is divergent to minus infinity. And if the sequence is not bounded and besides minus infinity there is no other limit point, then the sequence diverges to minus infinity according to your definition. Correct? Okay. So I am giving here 4 problems because tomorrow is Sunday. You are free. Sunday I am not going to send any notes or a video. Sunday you have to sit and solve these 4 problems. Question number 7, question number 8, question number 9, question number 10. Right? Of the 4, 2 are easy, 1 is tricky, other one you have to work very carefully. When you look into this one, 1, 2, 3, 2, 5, 2, 7, 2. Question number 9 is challenging. If anybody answers this perfectly, I will give you a prize. Question number 9, you will get a prize. Right? You will get a reward. Best reward will be given to you if you answer question number 9 and send me the answer immediately. Whoever sends the answer first will be rewarded. The finest reward will be given for answering question number 9. It is a challenging question for you, right? Okay, thank you very much. Please try to solve these problems. Thank you.